Welcome to APA's weekly webinar. My name is Billy Zadig, Manager, Special Projects for APA. Just a couple of housekeeping items before we get started. The webinar recording will be posted to the APA webpage later this afternoon. You will receive a follow-up email in the next couple of days with a link to the webpage where all webinar recordings are housed, as well as a link to our upcoming webinars. We have webinars planned out through the end of 2021, and many are open for registration. Professional continuing education and AIA CLU credits are being offered for today's program. If you are an AIA professional requiring a certificate, please send an email to me at Billie, B-I-L-L-I-E, @apa.org, along with your AIA membership number if you have not done so in the past. All attendees are in listen-only mode. Please type your questions in the chat box and they will be answered in the order they are received. If we run out of time and we still have questions, responses will be sent directly to the person asking the question by our presenter. At this time, it's my pleasure to turn this over to Amy Collins, who will introduce our presenter. Amy, take it away.
Thank you, Billy, and thank you so much for all. Can you hear me now?
You broke up there a little bit, Amy.
Okay, let me start again. Hi, everyone. It's Amy Collins from Gannett Fleming, and I'm here today with Gannett Fleming's Bob Widener for this APA webinar on the topic of bipolar ionization. While we're all getting to be old hat at this point about virtual presentations, please just do bear with us in case of any technical difficulties. And as Billy mentioned, Bob will be taking the questions that you might have at the end of the session, and we ask that you post yours within the chat feature. Our course today is accredited via the AIA, and you can see the course description here on screen. Next slide. And as such, we do have several learning objectives for the session today. So number one, we're going to dispel some of the common myths about indoor air quality. We'll help you understand guidance from ASHRAE regarding bipolar ionization, as well as other indoor air quality technologies. And then we'll help you learn about the long-term benefits of air cleaning technologies, such as DBD bipolar ionization specifically. Bob Widener is a principal project manager for Gannett Fleming. We're a global engineering, architecture, and construction firm based in Harrisburg, Pennsylvania area, but we have offices throughout the country. Bob, in his role, specializes in resolving complex mechanical challenges for a diverse range of client organizations, including those in the higher education space. As our firm's mechanical practice leader, he emphasizes high-quality deliverables and champions new technologies to move client organizations forward, enable financial savings, and increase sustainability. With more than 38 years of experience in the building industry, excuse me, Bob is actively involved with ASHRAE, where he serves as the Research Committee Chair and as a member of the TC 910 Laboratory Systems Committee. In addition, he's a member of the ASHRAE Epidemic Task Force, a group charged with addressing the challenges of current and future epidemics related to the effects of HVAC systems and disease transmission in indoor environments. I can tell you firsthand that Bob is very passionate about educating others about bipolar ionization technology. Throughout the pandemic, he has offered related sessions on nearly 100 occasions, and I've been really impressed by his passion and dedication to helping to share this message with all sorts of organizations. Since the start of the COVID-19 pandemic, colleges and universities, as well as the rest of the world, have reimagined and reinvented the higher education experience. But now, more than a year later, now that vaccine rollouts are gaining momentum and an in-person college experience might be likely next fall, What can we plan and implement now to help keep the spread of bacteria and viruses down and provide also peace of mind to the campus community? This session will explore air cleaning technologies that fuel a culture of collaboration and productivity while lowering the risk of in-person interactions. Gannett Fleming's goal today is to arm you with insight and information about one technology that could help college and university campuses everywhere speed up COVID-19 recovery efforts. And with that, I will turn it over to Bob.
Thanks, everyone. And thanks, Amy, for the introduction. So this is a brief agenda of what we're going to talk about today. And I know there's several people out there, so we'll do our best to I'll move this as fast as I can, and then we can try and do as many question and answers we can, but we'll also, I'll make sure we follow up on any unanswered questions. So as Amy said, it's been a crazy year for us. So we're going to talk a little bit about that, what we've learned about COVID-19 in the past year, how your HVAC system can help, making the case for BPI, installing BPI, and a lot of the technology comparisons that go along with the air cleaning technologies that are out there. So when we say a crazy year, when we started this thing, we were not even 10% of the lost lives we have right now. 32 million people have there are 32 million cases of COVID so far in the U.S. 574,000 lost lives, which is extremely significant. We all know about the healthcare systems being overwhelmed and the supplies depleted. Our unemployment, was at 3%, went all the way up to 15% at one point, and now it's kind of settled in the 6% range. The U.S. economy is still sluggish, especially the small businesses. We've learned a heck of a lot about social distancing, masks, gloves, shields, disinfectant sprays, wipes, etc. Gas prices were significantly reduced when there was less travel. Now you see that starting to make it up. The price is starting to move up a bit as we open the doors and start to travel. Also, the whole live sports and entertainment industry has really been impacted, especially even the stage and screen. So what have we learned about COVID? There's been a lot of discussion on how we get COVID. Certainly there is the person-to-person direct contact. There is the surface-to-person contact with surfaces and objects that hold the virus, and then we follow up by touching the surface and then touching our nose, mouth, or face. But the real thing that I think we've learned over the last year is that this really is an airborne respiratory type disease. And so the coughing, the sneezing, and even normal breathing put those particulates out into the air, and that's the primary concern. And that's why the whole discussion of masking is a predominant conversation piece. So while we've been going through this, there's been a lot of rethinking on spaces, reducing occupancy levels. And I think in most office buildings, you see that the case. There's a lot of virtual working. So we call it hybrid working. Some are in the office, some are not in the office, a combination of both. We've learned about development of re-entry guidelines, the space planning changes with physical distance analysis, face coverings, and a focus on expanded cleaning, new traffic flows and increased wayfinding, temperature monitoring, and basically a phased return to the new office normals. The images here are just basically what I just talked about in writing. You can see there's thermal imaging technology. This one, we're showing ultraviolet light. Ultraviolet's been a real common theme through this past year. That's ultraviolet light in an air handling unit. The virtual meetings, distance and masks in classrooms, the signage, even routing patterns inside facilities, all the different products for disinfecting, and even glass partitioning. But I'm here mostly to talk about how to help your HVAC system. We've learned with all the discussion between ASHRAE and the CDC that building owners have been told to take preventative measures with the HVAC system to reduce the risk of infection and then optimize the buildings for return to the workplace. So how have they said to do that? Well, the three things that they're focusing on and have been focusing on, and it really is an old playbook, it's increase the ventilation, bring more outside air in, maintain optimal humidity, 40 to 60%, and upgrade your HVAC system air filters. As I've said to people, these HVAC measures certainly can help, but they do have limitations. When we talk about increasing ventilation, it may be that our systems just can't handle that in one fashion or another. And then even in the peak seasons, now we're dealing with capacity issues that we may not have enough heating capacity and or cooling capacity to deal with that amount of outside air. When we talk about maintaining optimal humidity at 40 to 60%, that's fine and dandy in the summer, the summertime, but in most climates around the country, maintaining 40 to 60% humidity, especially in the wintertime, would be nearly impossible because our building envelopes are not set up to do that. The third thing here is, probably the primary thing that a lot of people have been focused on is upgrading the HVAC system air filters. We'll talk a little bit more about this in the Q&A period, but just so you understand, when people say we're going to go to MERV 13, there's some pieces of equipment that can't actually put MERV 13 filters in those systems. So that's not viable. And in other cases, when we do put MERV 13 filters in, there is an additional pressure drop associated with that. But then when you also look at the size of the bacteria and virus contaminants, you realize that they don't naturally get filtered out in that 100% in that type of filter. So we'll talk about that a little bit more, but that's something to think about. So my whole point to this is, I know it's an old playbook, I know what ASHRAE and CDC are saying, but I believe that these HVAC measures have their limitations and they do have issues. And so are there other options? And that's why I'm talking about BPI or bipolar ionization. So what have we learned? What is bipolar ionization? It's actually nature's cleansing process. Oxygen molecules are charged naturally through a high energy exchange of ultraviolet solar radiation and soil radioactivity. What does that mean? Essentially what's happening is there's a high energy exchange, ultimately an ion production that makes our mountain air fresh and enriched and healthy. And we also see this source of ion production in waterfalls, lightning storms, and ocean waves. So we need to understand, how does nature clean the air, okay? Well, with that ion production, they're able to agglomerate particles so that they fall out of the airstream. They're able to sterilize the particles through a mechanism, and then they're also able to oxidize. So those three things are the way nature goes about cleaning air. So what affects indoor air quality? These are several of the examples of what we would find in our air. It's particulate matter of various sizes, microorganisms like bacteria, viruses, or funguses, bioeffluents from people, VOCs coming from like auto emissions and those kind of things, and then materials, off-gassing, and mold spores. So when we talk about this bipolar ionization, or this ions, well, how do they help? If we look at what we would find in terms of ion concentrations in mountain elevations, you can see that both the positive and negative ions were up in the 1500 range, 1500 ions per centimeter cubed. As we move from the mountain elevations and we move into the rural areas, into small cities, into large cities, you can see how the ions in the air are reduced. But most significantly, once we get inside buildings, we're talking about an ion density of less than 10% what we'd find in the most pristine air. So how do we revigorate our the outdoor air? This next slide is going to go into a presentation by a company called Atmosair. They're one of the leading bipolar ionization manufacturers, and they specifically focus in on the DBD, or the dielectric barrier discharge technology, which I obviously am passionate about in terms of getting people back to the workplace. So I just want to share this a couple minutes of this video, and so hopefully everybody hears the sound.
You've probably heard someone say, "I'm going outside to get some fresh air," as if the air inside isn't fresh, right? Well, often it's not. Inside air can be loaded with airborne allergens, bacteria, odors, and other harmful particles and pollutants. They can make people sick, less productive, or absent from work, and all are costly to employers. Many of these contaminants spread from the inside, which means they're out of the reach of typical air filtration systems. Since we spend 90% of our lives inside, should we be paying more attention to inside air? That's why we developed ATMOS-AIR. ATMOS-AIR is the only indoor air purification technology that works proactively and within a space to reduce contaminants and pollutants. It restores inside air to what you'd find on a mountaintop. From offices to hospitals, stadiums to schools, ATMOS-AIR provides health and wellness benefits to keep occupants feeling healthier and more productive. Here's how it works. When outdoor air comes into a building, oxygen molecules are carried over specially designed bipolar ion tubes. An energy field converts these molecules into positively and negatively charged ions. These ions then travel into occupied spaces to seek out oppositely charged bad air particles, VOCs, and odors. When they combine, it forces them to break down and drop out of our breathing range to reduce contaminant levels and improve our health and wellness. And to show you it's working, our ATMOS-aware indoor environment sensors and monitoring system allow you to see your air quality in real time. ATMOS-AIR lets you confidently design HVAC systems according to ASHRAE's indoor air quality procedure, the more sustainable alternative to the ventilation rate procedure. The IAQP is approved by the EPA, USGBC, and is ASHRAE and IMC compliant.
Okay, I cut that video a little short because it tends to get to a little bit more marketing, and I wanted to focus obviously on the technical. That gives you a pretty good overview of the what's happening with the bipolar ionization process. Again, what we're trying to do is create in buildings what we find in nature. So we are basically bringing air, and it's a combination of not just outside air, but return air across these bipolar ionization tubes. They have a voltage potential that produces the ions, the oxygen ions, and then they go on into the space, and they basically are acting as a disinfectant because the ions themselves are able to reduce those contaminant levels. So how does the bipolar ionization help inside buildings? Basically, what you're seeing here is a couple tests that were done to portray dust particle decay with bipolar ionization. And so the orange here represents natural decay, and adding bipolar ionization, this was a predecessor manufacturer of ATMOS-AIR. But you can see that with the blue line in 15 minutes, a significant reduction of the dust particles in the air as compared to the natural process. Same thing was true with the reduction of mold spores. Although there's a reasonably significant natural decay, you can see that it's much more significant with the use of bipolar ionization. But obviously this year has been about COVID, and everybody wants to understand, well, can the technology help me with the coronavirus? And so these are tests that were done well before COVID was an issue last year. But this technology has been proven to deal with staph infections, E. coli, MRSA, what have you. And in a testing chamber, you're getting reductions of over 99%, anywhere between 15 and 45 minutes, depending on the contaminant. One of the things that you should know during this process, one of the kind of leaders in the understanding of how the bipolar ionization works is from Dr. Tierno. And in conversations with him over the past year, you know, he wanted to point out to everybody that when you're dealing with a coronavirus in the airstream, that you're dealing with a virus that is a 1 on a scale of 1 to 10, meaning it's very easy to kill. So how does bipolar ionization become that disinfectant? Well, essentially the mechanism, and this is the unique part, the mechanism is that when the ions are created and they're traveling through in your airspace, they will attach onto the fungus and the bacteria. And in that process, they're basically pulling off the hydrogen, and at that point they create they create this hydroxyl radical that basically kills the fungus and the bacteria. And that's the unique thing about bipolar ionization, but specifically about dielectric barrier discharge. There's a lot of technologies out there, you know, and you've heard them: the needlepoint bipolar ionization, the PCOs, the PHIs. There's all kind of different technologies, but the unique thing about DBD technology is, and that's the tube, is that you're creating a high voltage differential. That high voltage differential allows those ions, those super ions, to be created, and they're the ones that are significant in the fungus and bacteria kill. I show a picture of Dr. Tierno because he did a paper back in 2017 that really describes the process, how the ions are significant, and he basically concluded that BPI is extremely effective from a mold and pathogen reduction, particulate matter decay, VOCs and odor reduction, mold spore reduction, and also energy conservation. Also, recent research in the past year, they did a test on a sister coronavirus that you're able to access, and they showed that it killed the virus in 30 minutes. It was 99% kill rate. So I talked a little bit about the super ion, and that's the unique thing about this technology as compared to other technologies, is that it does produce the super ion. And the O2 negative ion that's produced because of that high voltage differential from the technology, it has it creates an ion that will last for basically 30 to 60 seconds. When that ion goes out, and when those ions are out in the space, first of all, when they're produced, because they can last for 30 to 60 seconds, they can actually get out long air duct systems, they can get into the space, and they have a lot of time to react with the bacteria and viruses. And in the process of doing that, they create, and that OH negative, it has a 2-second half-life. It takes out the hydrogen, and basically, it kills it. And like I said, the needlepoint technology does not produce this O2 negative. There's been a lot of discussion about bipolar ionization and all the issues with regards to ozone being produced and all that kind of stuff. And first of all, the technologies out there for bipolar ionization, whether it's needlepoint or DBD, they all produce or don't produce increased ozone into the space. We were out, well, for example, OSHA says that the limit should be 100 parts per billion. USGBC has suggested 70 parts per billion. ASHRAE has really pushed that level down to about 10 parts per billion. What I'm pointing out here is we were doing a study down in a school system in Maryland. The background levels were 10 to 50 parts per billion, depending on the time of the day. When we went inside and we were comparing two technologies, we found that the indoor background levels were 3 to 10 parts per billion, and when we used either the DBD technology or needlepoint technology, those ion levels never changed. Excuse me, the ozone levels never changed. I put this slide in here just to let people know that ionization has been around, for over 50 years. And the point here is that when they were first using ionization, it was primarily used for static control in the aerospace industry, in the electron building industry. But as time went on, the technology was able to be helpful in a lot of other areas. One area is that you would find very interesting is where the technology really started to kind of change a little bit of focus. It was over in Europe in the meatpacking industry. They were using the technology to try and reduce the molds and bacterias in the meat processing. And what they found is that the technology was so good in doing that they did not have to refrigerate it as cold. The United States still does very, very cold refrigeration, but in Europe, they use this technology and they don't have to go as cold with refrigeration. So that's a really interesting little piece of information. So the next step here, I want to talk about how we incorporate it into the system. This is not rocket science. It's very adaptable to existing systems. If you look here, we're looking at pretty much a standard air handling unit system. We're bringing outside air in through a duct system. We have return air coming from the space. Those two air streams mix. They go through the air handling unit. And at the discharge, whether it's the discharge plenum or the duct systems, that's where the ions are produced and then pushed out into the space. And that's where they do their magic. Here's a couple examples of the bipolar ionization tubes being put in. This one's a case of a large air handling unit plenum. This is a air handling unit discharge duct. The tubes would be projected into the ductwork. Here's another example of a different plenum application. And those are typically for medium and large systems. But the technology is also adaptable for fan coil units. You see the little tube here, small ducts, and then even variable refrigerant systems, cassettes. You can see the tube in there. There is technology out there to monitor your indoor air quality by looking at particle masses, total VOCs, CO2s, temperature, humidity, and then you can use that to determine an overall air quality index in your building. So there is technology out there that you can do that with today. People ask about the maintenance. One of the things about these tubes is that over time, the ion production starts to drop out. They're usually recommending around every 2 years. You replace these bulbs, you're talking about something that's about 10% of the cost of the original installation. Oh, and the other thing about this is where it gets into the energy side of things. When we look at what are the things that ASHRAE and CDC are saying about the increased filtration and outside air ventilation, when you put these tubes into your system, there's pretty much a negligible air pressure drop, and they have very little amperage draw. So the quality of air that you're getting and the energy component is very insignificant. When I talk to people about costs, because everybody wants to know what the costs are, my general rule of thumb is, and these are the components, whether it's the equipment, the engineering support, the labor, etc. But you're looking probably in the area of the country that I'm in, central Pennsylvania, we're looking at about $1 a square foot or $1 a CFM. Obviously, if we get into the larger cities and areas of metropolitan areas, we might have the we're going to have higher labor costs, so those numbers could jump. But in our area, this number seems to fall into place pretty well. One of the things that was mentioned in the video was the ASHRAE 62 indoor air quality procedure. And this is where it comes into playing with the energy. If you're able to improve your indoor air quality with an electronic air cleaning technology, you have the ability then to use the IAQ procedure, which actually will allow you to reduce your outside air ventilation. And for you guys on the facility side of things, if you're able to reduce your outside air by using this technology, you can imagine the significant energy savings you could have. So usually you'll find you probably have a 2 to 3 year payback by putting this technology in and taking advantage of reducing the ventilation. Now, certain ventilation is required for certain things that's up and beyond the code. So obviously that can't, you just can't blanketly say we're going to just reduce it. But using this procedure, it's ASHRAE's procedure, you can take advantage of that. I'm not going to spend a lot of time on this slide, but this is a slide just comparing the technologies and where the strengths are. Obviously, you can see by this, that I've been leaning towards the BPI DBD because of its ability to do all these things. Whether it's odors, VOCs, bacteria, viruses, etc. It's a very significant product. We know about media filtration and what you can do, and I'll talk a little bit more in the Q&A if we have time about filtration, but the bottom line is it's not going to do what BPI does. Ultraviolet is a very good technology, and it's a very, it can be in parallel, if you will, with BPI. But what ultraviolet is really good at is if it's focusing its light for a long period of time on whether it's coil surfaces or filter surfaces, it will do its job. It does not have enough resonance time for air that's passing through at the velocities they are in air handling unit systems to kill the viruses and bacteria. So it good inside the units for surface killing, which is great, but it's not the end all. PCO is another technology where they use ultraviolet light. They put it, they shoot it onto a specific metal. It produces that what I'll call the super ion. The thing is, it produces it only there at that time, and it's only a 2-second kill period. So in reality, it doesn't have the same effect as does the BPI technology by getting the ions out into the space. The needlepoint ionization, there is a lot of good about needlepoint ionization, but the couple things that should be pointed out is that it does not have the ability, despite some of the false reports that have been pushed out by the manufacturers. As best we can tell, it does not kill viruses and bacteria. What they'll claim is because of the agglomeration, the virus and bacteria can get captured. It'll drop out of the airstream, whether it goes to the floor or get captured at the filter. But in terms of the actual kill, we've seen nothing truly that validates that. PHI is just like PCO, just a little different process. So some of these slides I'm just going to go through and just kind of I'm going to try and leave as much time for Q&A, but everybody always asks about reports. What is there? What's the third party testing? What's out there that makes me really confident that this is going to work? So I'm going to share some of this stuff with you. There's more out there. I will tell you there is no ASHRAE standard at this point to test different air cleaning products, and that's why ASHRAE is reluctant to make a statement or endorse any particular product until they've completely tested it. Well, that could go on for 10 years, and that happened with UV. It happened with variable frequency or VRF technologies. ASHRAE doesn't move that fast. So I think in most cases you have to kind of do your diligence and decide if the tests that have been done outside of ASHRAE make you feel that this product's viable. So there is an ANSI test regarding the clean air delivery rate, or the CADR. And if you look at this, you'll see that Atmos Air's technology was compared to a PCO technology, a Honeywell air cleaner, electrostatic air cleaners, a negative ion generator, and needlepoint ionization. And you can see that the clean air delivery rate in terms of that technology is significantly better than the other technologies. This is a test where they were looking at the effects on microorganisms in a healthcare institution in Chicago. You can see that these are the pre-atmosphere air values, and after all these values, after they turned on the system, there was none detected. So they basically, had 100% kill rate in that particular test. Let's go on here. This is DBD versus VOCs. Syracuse University lab did this, and they were showing how to get rid of some of these odors, and you can see like hexane, butane, butanol, toluene, etc. So they start out, and over time, you can see that the reductions were pretty significant down at the bottom here. Okay. I just show you a snapshot of some of the educational systems that have used the technology. I wanted to point out a University of Southern California case study. I had actually talked to one of the facilities guys there, and he had indicated, you know, that they were really having a problem in their athletic facilities with staph infections, and it took them a while to make a decision as to whether to use BPI or not. There was a lot of discussions back and forth with the manufacturer, but ultimately they decided to go through with the technology. And in addition to significantly reducing their staph infections, they were able to reduce the VOCs by 90%, particle masses of the 2.5 micron down to 50%, and the larger particle masses of 10, a 95% reduction. So pretty significant. And like I said, the conversations with the gentleman out there, they said they couldn't have been happier. Several weeks back, I was doing a panel discussion with some of the experts in the field, and I thought I'm stealing a slide here from Giles, but he indicated here, this is an elementary school, and I just reading a quote here. We have noticed a decrease in allergy symptoms and bacterial infections with adults in the classroom since a purifier has been in place. Also, I've noted less health office visits from children with allergies and asthma. This one is from the Greek Peak Mountain Resort. It says, from opening day to present, our guests and staff have enjoyed the air quality produced through your atmospheric purification. And I think that one of the things that was really significant here is they talked about, you know, they have a pool that's open up to an open area. And when they put the technology in, they were able to significantly reduce that chlorine smell so it wasn't obnoxious. So that was a pretty impressive finding. So I talked a little bit about energy and energy performance. And if you go and use the IAQ standard like the US Army Fort Belvoir did in one of their buildings, they were able to significantly reduce their energy costs. Their energy consumption costs were $363,000, and then after they were $306,000. So they were able to, by introducing BPI in their facility, able to save, you know, $57,000 a year. So pretty significant, like a 28% reduction. Okay, I kind of flew through that. I left some time here for Q&A, and I guess, Amy, you're going to push the questions out to me. Amy?
Yep, that's right. Thanks, Bob. Can you hear me okay?
I can.
Very good. So we did get quite a few questions, so thanks so much to everyone that submitted a question. We'll certainly try to get through as many of them as possible, and I am going to try and hit the ones that I know are kind of the more frequently asked questions. And as Billy said, if we don't get to your question, we will certainly follow up with you either today or sometime later in the week to finish the conversation. So, Bob, I'm going to just start with this one. What is the human reaction, if any, to ionized air? And what about associated research?
Let me go to a slide here. There's different human reactions. Some people didn't realize that the technology was in place, and they found out just over time. They thought, "Boy, it feels fresher in here. Something's different." And so that's been some of the feedback I've heard. I can tell you this personally. Obviously, Amy says I'm passionate about it, and people tease me, I drank the Kool-Aid, what have you, but I put the technology in my house, and I have several employers at Gannett Fleming that now have the technology in their house. I have not felt better in terms of waking up in the morning and not having sinus congestion and that kind of feeling, and trying to clear myself out. That's how it's benefited me personally. I don't have any odor change, if you will. From my standpoint, there's been no odor change in the house. Some people say there is a different, feel, whether you want to call it freshness. So it's very subjective. But I think what I'd like to show here, just go through this slide real quick. It's just, some points about some of the issues that come up about bipolar ionization. So ions already exist and are abound in nature. That's the fact. There is enormous conflation of information on a myriad of devices that do not work at all. And that's kind of what I've been alluding to and trying to educate people on. And bipolar ionization equipment should not be categorized as ozone devices. If you go, if you do search after search, you're going to find, people say that it produces ozone. And the fact of the matter, it doesn't, and it's a UL proven device. And when I say it doesn't put ozone into the space. Anything that's an electrical device will have some ozone production. The question is, does it do anything to the space? And the answer is no. And that's why it meets the standard. I talked about the superoxide radical that's produced, this super ion, the O2 negative, and that's unique to DBD technology. But it's interesting to know that when you talk to Dr. Tierno, that superoxide radical is quantitatively the most important radical formed in humans. That's what we use to kill things. So when people say it's dangerous, these superoxides are dangerous, it's not true, okay? It's also important to understand the remarkable difference between microbial and human cells. So people talk about the idea that, oh, the human body can't handle these ions and what have you. It's not true. They're in nature. All we're doing is reproducing what nature produces. The hydroxyls that people, kind of complain about without real understanding is that they have a half-life of about 2 seconds. That's a process where you're killing the bacteria and virus through that absorbing that hydrogen into a chemical or a biological type of thing. The positive ions produced are unstable and they tend to combine with excess negative ions neutralizing. This is a very significant point when discussing needlepoint bipolar ionization. When needlepoint produces its ions, they're linear. They have whether they're needles or carbon fiber, they're pushing needles out in a linear fashion, and they're right next to each other. And they're not the same ion, the O2 negative. They're an O2 double negative, but when they're going out, they're like hitting each other and getting absorbed. So they have to overproduce that ion just to get it out into the space if there's a long ductwork system. And again, that ion that they're producing doesn't have the same ability to kill bacteria and viruses. BPI uses the agglomeration to improve IAQ. BPI DBD does not affect residential normal flora. And overall, there's an addendum approved. So this is a lot of stuff from Dr. Tierno saying, debunking a lot of things. And I took a little time there, Amy, but I wanted to get through some of the hot issues that probably, needed to be addressed there. Go ahead.
No, good stuff, Bob. Thank you. A question that we frequently get, and one that was posed here, this relates to UV, and there's been so much discussion about installing ultraviolet lights. Yeah. This person is asking, why not just install UV lights only in the duct streams? Well,
first of all, it would be very expensive, extremely expensive. And so the light cost is very expensive and people don't realize it. Plus, it's a high electric energy user. It's not that you can't do it. It just doesn't ultimately make sense from a cost and energy standpoint. That's the reality of it. You have to have enough light there to be able to, essentially deal with the residence time that's required. And that's why ultraviolet is much better on surfaces, because it has a lot more time to kill it, So that's the straightest answer I can provide.
Great, thanks, Bob. Here's a question for you regarding the increasing of ventilation. The question was, does increasing ventilation have the possibility of increasing turbulence in the space? And is that detrimental to controlling the spread of the contaminants that we are trying to control?
No, I mean, basically what you're saying, when we increase the ventilation, I mean, if you say I'm going to increase the overall ventilation, in other words, I'm not exchanging return air for outside air, that's a different thing. So if you're saying I'm going to increase to 4 to 6 air changes an hour, that's not going to significantly impact. The thing about outside air is and the goal is when you put outside air into your building, you're reducing. It's like we call it killing pollution by dilution. Okay, that's what you're doing. You're bringing in fresh air that doesn't have the contaminants in the space, and you're basically, by removal, by bringing ventilation, you're reducing the potential amount of remaining contaminants in the space. That's the significant part. If you don't increase your overall ventilation significantly, as long as your diffusers are designed to take that additional ventilation, that's fine. But the key thing is the outside air ventilation. My point to that from an energy standpoint is, can your system handle it, especially during the peak winter and summer times? Is your system designed for it? Was your outside air isn't a full economizer? Some systems don't have economizers, so how are you going to do that? You know, so it's just that you have to everybody has to look at their own situation and say, what best serves me? Whether it's increased outside air ventilation, overall ventilation, filtration, or humidification, those are all energy hogs, right? And so, granted, you're in a COVID time, you got to do what you got to do. But long term, does that make sense? Are we going to accept that? I mean, I'm not even sure ASHRAE is going to accept it over time. So I think that's why I'm purporting the technology of bipolar ionization.
All right, sure. I have a kind of a two-parter here for you. What's the benefit of using ionization technology instead of, excuse me, instead of using semiconductor airport contamination reduction technologies? And then also, what's the benefit of using this technology instead of, say, a MERV 13A filter?
Okay, the first one's a little over my head with regards to whatever technology they were talking about. I'm not exposed to that, no pun intended, so I'm not going to answer that. If they can provide clarification, I'll try. The reality is that, let me go to another slide here. I had this in here because everybody talks about filtration. So if you understand filtration here, this is you're showing a scale of MERV 1 down to MERV 20. What you need to understand here is that from MERV 17 to 20 down here, these are HEPA or ultra, low particulate filtrations. Notice it's MERV 17. They will get 99.9% of all the contaminants that are passing through an airstream. When people talk about MERV 13, they're getting less than 75% of the 0.3 to 1.0 microns. And that's the size of the bacteria and viruses. So you hope for agglomeration that by chance it sticks there, right, and gets caught in the filters. But again, the thing I would point out is, first of all, the HVAC system might not be able to handle it. And what they found is that if you actually insert bipolar ionization to your system, the effectiveness comes out in such a way that with a MERV 8 filter and BPI, you can get the same effectiveness of a MERV 13 easily. And that's pretty important. So the idea of using a MERV 13, again, is not the end all. It's not getting it all. And it's an energy hog and may not be able to be applied to the systems that they have. Okay.
All right. Here's another kind of frequently asked question. With the end of COVID-19, maybe being closer to having the end in sight here, is the expense of implementing BPI worth it? At some point, can't we just return to normal with normal HVAC operations? It appears to be a substantial expense with short-term gain. Any thoughts?
Yeah, you see the slide. So when we did our panel discussion, again, I reached out to a lot of the experts in the field, and what we found, if you go back to the initial slide I said and talk about the ion concentrations inside as compared to outside was only 10%, right? Well, there's been a lot of studies out there regarding poor IAQ and the significance of going from a traditional design to green design or green plus design. What you find out is that the cognitive value of going to a much cleaner indoor air quality building is significant, right? Okay, and I want to show you one more slide. So if you look at the economics of poor indoor air quality, and you're trying to get people back into space, and I'll be honest, you can say that COVID's going to go away, and it might. Okay, but we're going to get booster shots every year. What's the next virus that's coming along? Plus, we still have influenza and other things that are in the office. Well, so besides the medical side of things, when you take all that into fact, a 3.8% decrease in office task performance from poor IAQ has been found out to be cost, that office or, that building $300,000 a year in wasted salary and benefit expenditures annually. And there's multiple studies on this. This still happens that if you look at the source here, the gentleman that we had, Bill Browning, was the the author of The Nature of Air, and he's the one that presented on this. So that's really, I think, and that's where I'm going with this. The next step is, I really think that in time, of course, when ASHRAE, we start to get, I'm working on the protocols for testing, but when we get to that point, I think you're going to find out that these technologies, whatever ones are successful, are going to be codified in an amount of time. I think people are going to demand that that's in our buildings, that this is the way we're going to go. Go ahead, Amy.
All right. So someone posed the question just regarding APA webinars, and I'm sure many others on the topic of indoor air quality. And the knock is often on BPI in that there's no evidence that it works in a quote unquote real world setting, not just in a chamber. Why isn't there such testing?
There is testing, but it's not, it's private, and that's the challenge. And that's where ASHRAE is. ASHRAE wants to, have a test done by them, performed by them, paid by them, et cetera, or, what have you. So it's, you have to rely on the research that's been done. So what I shared with you, and just is a piece of it, is just letting you know that there is a lot of private testing out there. You just have to be able to get it. You're not going to always find it on the internet. So you have to look to companies that have used the technology, provided evidence, provided studies, but there is private stuff. In addition to that, I showed you some examples of lab studies, third-party lab studies that were done, and they were legitimately done. They were done in such a way that the ion concentration used in those tests was consistent with the ion concentration that would be required in a space. Some of the other manufacturers have played games with that in doing their testing, and have overproduced and did things that really weren't, scientifically the way you should do things. So you have to dig. Obviously, I'm a resource. I'll be glad to, support, or, in whatever you want to do with regards to your facility. I'll be glad to support you in providing additional information so that you can, move forward with using the technology.
Thanks, Bob.
Next thing.
The next question, I guess, is really more of a statement, but I know you're going to have some thoughts on this one, Bob, so I'll share it with you. The person says, reducing outside air, even if you have some mechanical or technological justification, really goes against everything that is being represented to the public right now, all of whom have access to the internet, and of course are self-proclaimed experts, right?
Yep.
And this would probably result in great controversy among facilities professionals and the public in general, especially folks like faculty on college and university campuses.
Yep.
What are your thoughts there?
Amen. I agree. It's not going to be easy, and there's people on both sides of the aisle. I would say ASHRAE is extremely conservative here, and they're not going to do anything with regards to that. But the fact of the matter is, there is a guideline in the standard that allows it to happen. So here's my recommendation: is first, put the technology in. Don't worry about the outside air reduction right away. That would be my first piece. Secondly, it can be tested. If you want to look at and what we're doing at a facility, we introduce it to a gymnasium project for a Maryland college, and we put it in, but we're using the technology to say, okay, what's our CO2 levels and what's our indoor air quality levels? CO2 drives. So if our CO2 levels get to a point that, you know, they're too high, then that's going to open up the outside air. But why not take advantage of a technology that's doing that, looking at the overall indoor air quality and then looking at the CO2 levels. There's no reason, if you have good indoor air quality, there's no reason to over pump outside air in when the air quality from a CO2 standpoint is good. And we can debate about the different surrogates in an air system, but with the technology I'm talking about, when you're reducing the VOCs, you're reducing the particle masses, you're dealing with bacteria and viruses, you're dealing with all those things that contribute to, you know, whether it's human health issues and or poor performance. When those things are not in the space and you keep the ventilation rate, that's what's consistent with guidelines, I don't see any reason why you can't reduce the outside air. And yes, that probably goes against a lot of people in ASHRAE, but I don't think, you know, I think I'm on the right side of this, you know, going forward.
All right, Bob, we have a couple more minutes here, and I know we have more questions and we'll have time to get to, but let me give you a couple more here.
Mm-hmm.
You know, one person's asking, can you comment on the value of introducing BPI to only one location of a campus if the rest of the campus is not treated?
Well, here's what I would say, and I'll say it to, there's some people out there that I know of universities that I'm trying to convince them to use the technology. And I've said this to a lot of people that we do in this presentation, beta test it, prove it. We'll be glad to test before and after. But prove to your constituents by taking the opportunity to put the technology in. It's not that expensive. You're talking about $1 a CFM. So if you have an air handling unit to a space, we can monitor, we can prove the quality of the air has improved, and you can just move that forward. Do a beta test. We're working with clients that are looking at the same thing. They're going to beta test a site, and then if it works to what they expect, then they'll push it out to other buildings. And I realize there's a lot of, I say it's only $1 a square foot, but, or $1 a CFM, but I've been looking at what people have been doing across the country to try and, figure out how to get people back into their college, universities, their office buildings, and the money they're spending. This kind of does a lot for the cost, a real lot. So I would beta test it, and then build the case and go to management or the leaders of your college, university, etc. And I know it's a fight. Believe me, like I said, I know I'm talking to people that know who I am and that I've been pushing this at their universities and colleges, and it's very frustrating, especially when you're an alumni. So anyway.
All right, Bob, last question for you. You are an advocate for the DBD bipolar ionization over the needlepoint technology.
Yep. Correct.
Could you just explain the difference again? Is it the quantity of ions produced? Needlepoint, this person says needlepoint seems to last much longer. And then also, what is the cost of the replacement tubes?
What's the last part of that? What's the cost of what?
The replacement tubes.
Oh, okay. I don't have specifics on the cost of replacement tubes. What I was looking at initially was about 10% of the original, initial cost. So I guess you would say 10 cents on a dollar for whatever you spend in the system might be a good, a good number. And it's not rocket science to replace the bulbs. It's just like replacing a light bulb. So the needlepoint, this debate's going to go on and on and on. And unfortunately, when you look at the websites, there's very good marketing on a lot of the technologies, but the evidence is just not there. DBD-BPI technology has been around for 50 years. It's been studied much more significantly. There's much more case studies. And all I can tell you is, I'll give you an example. I talked about the school. We were, looking at the technology comparison, and we looked at the ozone levels. What I didn't tell you is we looked at bacteria levels too. And I did not share that in today's presentation. But that school was pretty well cleaned. There was nobody in the school when we were doing it. We tested 2 unit ventilators, and we tested a library air handling unit system. In the one ventilator, we had a needlepoint technology, one of the leading manufacturers, and the other one we had a leading, we had BPI DBD. And we also, we had the same 2 technologies in the air handling unit system. There wasn't a significant difference because the building was so clean in terms of the VOCs and the particle masses. The building wasn't occupied, so there wasn't a lot going on. So we didn't see a lot of difference there. But what was interesting is when we did the bacteria sampling, which we sent to a third-party lab, when that information came back, we noticed that with the needlepoint technology, the bacteria didn't decrease at all. In fact, you know, over the timing of it all, it increased. Where when we had the DBD technology on, the bacteria counts were reduced by almost 75 to 80%. And that told me a lot with regards to the technology. And I was also working with a guy that really understands the technology differences and what have you. And you won't see that. I mean, you won't see this stuff, you know, just glossed out on, you know, anybody's website. But that was pretty significant for me. If it can do that to bacteria, the other technology doesn't. And there's with regards to needlepoint, if you have not seen, a major manufacturer just came back that was using needlepoint and basically had a significant debuff, if you will, of needlepoint. You might want to research that and get a little opinion. But I've been not a fan of needlepoint. I've stated so. People know that. And I probably have a few enemies because of that. And I've probably I've had a couple of people that, you know, decided to go that route, and I said, I hope it works out for you, but I don't think it's going to, you know. So anyway, that's my answer to that, Amy.
All right, very good. Well, I know we're a couple of minutes over at this point, so I do really thank everyone for hanging out with us this afternoon and for all of the really excellent questions. We will get back to you. Billy, did you have any last words you wanted to share with the attendees?
I do just want to thank Bob for putting on such a great presentation. Amy, thank you for moderating. And to our attendees, thank you so much for taking time out of your busy schedule. Until next time, be safe, stay healthy, and have a great day. Bye-bye now.
Thanks, everyone.